Hello, class. So in this video, we're going to cover 7.1, which deals with verifying identities. Chapter 7 in general deals with a bunch of identities and verifying and also some solving. Okay. All right. So 7.1, verifying identities. Okay, so what I'm going to do first is start off with simplifying, and then that leads into verifying. Okay, so last time we talked about the Pythagorean identities, so let's just kind of revisit that. Hopefully you have these memorized by now. Okay, so we have sine squared u plus cosine squared u equals 1. We have that one, and then if you divide everything by sine squared, or you divide everything by cosine squared, you get the other two. Okay. So we have 1 plus cotangent squared equals cosecant squared. And then we also have tangent squared plus 1 equals secant squared. Okay. I'm going to give you some more identities. The cofunction identities. Okay, so these are the ones where you have sine pi over 2 minus u equals cosine. Okay, so maybe you remember these, maybe from trigonometry. Okay, and so we also have cosine pi over 2 minus u equals sine. Okay, and cosecant pi over 2 minus u equals secant u. These, I mean, they're kind of easy to memorize, but normally I would have you guys memorize the Pythagorean identities for a test, and then the rest of them I would give you a sheet with all of the different identities and formulas. But it's nice to have this one memorized, because when you're verifying identities, it's nice to have it ready in the back of your mind, instead of having to try to find something. Okay, it's best to have that easily accessed. Okay, secant pi over 2 minus u equals cosecant u. And then tangent pi over 2 minus u equals cotangent. So cotangent pi over 2 minus u equals tangent. Okay, and then we have the ones for odd and even functions. Okay, so if you have sine of negative u, that's equal to the negative of sine u. If you have cosine of negative u, then that's going to be the same as just cosine of positive u. And you can kind of see that to be true for cosine. Let's say cosine pi over 6 versus cosine negative pi over 6. Okay, cosine pi over 6 lands in quadrant 1. Cosine negative pi over 6 lands in quadrant 4. Okay, and in both those quadrants, the x value is positive. So that's why cosine of negative u is going to be the same as cosine positive u. Okay, and then tangent Okay. And then, of course, the same will be true for the cosecant, secant, and cotangent. Okay. All right, so let's take a look at simplifying before we do some verifying. Because verifying is just, it's simplifying, except you know what your final answer is going to look like. Okay, so let's take a look at simplifying. All right, so for example, suppose that I have this tangent x, cosecant x. Okay, so one of the recommendations is to try to get everything in terms of sine and cosine, and then see if anything will cancel. Okay, so let's try to do that. Okay, so tangent is sine x over cosine x, and cosecant is 1 over sine. And oh, well, what do you know? Sine x and sine x cancel out. So that's why it's kind of nice to have it in terms of sine and cosine. And so we end up with 1 over cosine, but we know what 1 over cosine x is. That would be secant. Okay, so whenever you have a 1 over trig function, make sure you simplify that. Okay, and that would be it. Okay, all right, so let's take a look at another one. Okay, let's take a look at this one here. Suppose that you have to simplify 1 minus cosine squared x times cosecant x. Okay, so in the first example, we didn't have any squares, right? But in this example, we see cosine squared, and we also see that 1. Whenever you see ones and a square, like here, 1 and cosine squared, you should be thinking um, Pythagorean. So let's go back up here. Can we rewrite one of these as a 1 minus cosine squared? Yes, that would be the very first one, right? That would be this one. Sine squared plus cosine squared equals 1. So 1 minus cosine squared would be equal to sine squared, right? From right here. Subtract cosine squared on both sides. So we see sine squared equals 1 minus cosine squared. Okay. So here, this 1 minus cosine squared, that I can go ahead and rewrite that as sine squared, right? And this cosecant is the same as 1 over sine. Okay. And now remember, that's this here's sine squared x. That's the same as doing this sine x squared. Okay, we just write it on the inside there. So hopefully you know that from trigonometry. Okay, so when I cancel this, I end up canceling one of these with one of these. And so I'm left with sine x. Okay. All right. Let's do one more, and then we'll do verifying. Okay, suppose that I have this cosine squared x times secant squared x minus 1. Okay, so again, here I have the square and the 1, right? So looking back at your Pythagorean theorem, Pythagorean identities, secant squared minus 1. Aha, so we can see that we can get secant squared minus 1 here, right? If you subtract 1 on both sides, you'll get secant squared minus 1 equals tangent squared. Okay, so let's go ahead and go here. So I can go ahead and rewrite this secant squared minus 1 as tangent squared. Okay, great. And here, let's go ahead and rewrite everything in terms of sine and cosine. Okay, so we'll keep this one, but tangent squared can be rewritten as sine squared over cosine squared, right? And then we see here that these will cancel out. And so you're left with sine squared x, okay? Okay, so that's simplifying. So verifying, if I rewrote these as verifying problems, this first one here would say verify that tangent x cosecant x equals secant x, okay? And then you would just show your work, okay? The second one would say verify 1 minus cosine squared x times cosecant x equals sine x, like verify that, okay? And you just show all the work in between, okay? Verifying is a little bit easier because you know what you're aiming for, and so you know when to stop, okay? Simplifying could be tricky for some students because they're not sure if they're done. They're not sure if they're like, oh, should I do this, simplify this part some more? Okay, but with verifying, once you get it to look like the other side, you're done. Okay, so let's go ahead and have a look. Okay, so verifying. So you're going to have to verify that something equals something. So you start with one side, generally the more complicated side. Okay, start with only one side. Okay, and try the more complicated side. Not necessarily, but you know, it's usually easier to simplify a complicated side than one that doesn't look very complicated. So try the more complicated side. Okay. Uh, and try converting to one trig function. Okay. Or else sine and cosine. Okay. Okay. All right, so let's take a look. Let's go ahead and verify that secant y cosine y. So normally, like if this were a simplify problem, they would just say simplify that. Simplify secant y cosine y. Okay. And then you'd have to figure out what it's going to equal at the end. Here, for verify, they're going to tell you what it's going to equal at the end. So verify that secant y cosine y equals 1. Okay. So we're going to verify. So what we need to do is we need to show that when we take secant y cosine y and we simplify it, we need to show that we get 1. Okay. All right. So, and clearly, so this is what they mean by start with the more complicated side. Between the two sides, secant y cosine y, and the other side, which is 1. Of course, the left-hand side is a little more complicated. So we're going to start with that side and simplify it, because how are you going to simplify 1, right? Okay, so secant y cosine y. All right, so we have different trig functions, so let's try to rewrite it. We know secant is 1 over cosine. And then we have cosine here. And then we see that they cancel out, and we get 1. So we verified that secant y cosine y equals 1. Okay, once you get that other side, you're done. Okay, let's take a look at another one. Verify cosine squared beta minus sine squared beta equals 1 minus 2 sine squared beta. Okay. All right. So these actually both look equally complicated, each side. So you can probably start on the right and end up with the left, or start with the left and simplify it and get the right-hand side. I'm going to start with the left-hand side. Okay, I'm going to go ahead and take the left-hand side, and I'm going to simplify it. I'm going to simplify it until I get it to look like the right-hand side. All right. Now I notice that the right-hand side is all just sine. Okay, so then I'm going to go ahead and I'm going to rewrite my cosine squared in terms of sine. Okay, and again, we have squares, so let's go all the way back to here. This is why I say try to memorize it. That way you don't have to keep going back and forth. So I have this top one, again, this one, okay? So cosine squared will be equal to 1 minus sine squared, right? Cosine squared is equal to 1 minus sine squared, because you move that sine squared over. Okay, so going back to the problem. All right, so over here, cosine squared is 1 minus sine squared. And I'm going to bring down that minus sine squared. Okay, so then here, I'm going to remove my parentheses, and I am going to combine like terms. So I get 1 minus 2 sine squared betas. And that's what the right-hand side is, so I can stop simplifying. I can stop right there. Okay. All right. Let's take a look at another one. Let's verify that cosine x plus sine x tangent x equals secant x. Okay, so again, try to start with the more complicated side, because it'll probably be easier to simplify cosine x plus sine x tangent x instead of trying to simplify secant x. Okay. All right, so let's start with the left-hand side. Cosine x plus sine x tangent x. Okay. And we want to try to get this in terms of one trig function. We have 3 of them. Okay, so then next best thing, try to get it in terms of sine and cosine. So then let's try to rewrite that tangent. So we'll rewrite tangent using sine over cosine. Okay. All right, and so then that gives me cosine x plus sine squared x over cosine x. Okay. And one good rule here, when you have 2 terms and you have like fractions, right? Like we do here, is to definitely go ahead and add your fractions, get your common denominator, and then see what you get. Okay, so let's see what we get here. So this cosine x is like over 1. So my LCD here is going to be cosine x, right? And so the right-hand side, I don't need to multiply by anything, but over here, the right fraction. So here, I need to multiply by cosine x over cosine x, which is 1. Okay. All right, so then that gives me cosine squared x over cosine x plus sine squared x over cosine x. Okay, and so now that they have the same denominator, I can go ahead and add these two fractions. So I get cosine squared x plus sine squared x over cosine. And we know what sine squared plus cosine squared is. It's 1, right? So then I get 1 over cosine x. We get 1 from the Pythagorean identity. Okay. And then 1 over cosine is secant x. And I believe we are done showing that it equals the other side, right? Let's take a look. Yep. We have to simplify until we get secant x. And we do. Okay. So we're done with that one. All right, let's take a look at another one. Verify that secant 6x, secant x tangent x minus secant 4x, secant x tangent x. Verify that this here equals secant 5, secant to the 5th. Let me make that look more like a 5. X times tangent cubed x. Okay, so clearly here the left-hand side, which is on top there, is the more complicated side. So let's try to simplify that longer one. And let's try to simplify it till we get secant 5x tangent 3x. All right, so we have secant. I'm going to rewrite it over here. Okay, so here, in this particular case, we could use, we could factor. Okay, so we could factor out, a bunch of things. Okay, so we could factor out secant x tangent x, right? And we could factor out up to 4 of these, right? Okay, so let's go ahead and do that. So we're going to factor out secant x tangent x. And we're going to factor out up to 4 of these. Okay, and if I do that, I'll still need 2 more here. So secant 2x. And over here on this next term, I don't need anything. So I'll put that. Okay, we have a square and a 1. Square and a 1, you should be thinking Pythagorean. Okay, so when you think of Pythagorean, secant squared minus 1, if you look back, secant squared minus 1 is tangent squared. Okay, so this piece here is going to be tangent squared. Okay, and over here, I'm going to combine the secants. So I'll get secant 5x tangent x, and that one's tangent x. And then I can put these tangents together, and I will get secant to the fifth tangent cubed. And I think that's what we are supposed to get. Let's see. Let me scroll up. Secant fifth tangent cubed. And that's what we have. Okay, so we can stop here. So you're going to be pulling out all of your magic tricks in math, your math magic. All right. So to simplify, so it could be factoring where you factor things out. It could be, getting common denominator to combine your fractions. Okay. It could be something simple as looking at your Pythagorean identities. Okay. So you're going to be using everything you know, okay, to try to simplify these. Okay. Let's see. Let's do another one. Let's do one more. Okay, so let's do one with fractions again. So let's verify 1 plus sine theta over cosine theta plus cosine theta over 1 plus sine theta. Verify that this equals to 2 secant theta. Okay, so I'm going to use the left-hand side and try to simplify it until I get 2 secant. Okay. So 1 plus sine theta cosine theta plus cosine theta over 1 plus sine theta. Okay, so I'm going to work on this side, and I'm going to simplify it. All right, so here I have fractions, so I am going to get my common denominator, which is cosine theta times 1 plus sine theta, right? Okay, so I'm going to try to get my denominators to look like that. Okay, so cosine theta, this first fraction, I need to multiply by 1 plus sine. Over 1 plus sine, which is basically 1. And over here, I'm going to have to multiply by cosine theta over cosine theta. Okay. All right, and then let's see what we get. All right, so we get 1 plus sine. Here, let me write it down. So I get 1 plus sine theta times 1 plus sine theta. And then over here, I'll get plus cosine squared theta. I'm going to get all over cosine theta, 1 plus sine theta. All right. Okay, I'm going to go ahead and multiply out the 1 plus sine theta times 1 plus sine theta. Okay, that's just 1 plus sine squared, 1 plus sine theta quantity squared. So you're just squaring a binomial. So when you do that, you should get 1 plus 2 sine theta plus sine squared theta. If you don't know how to square a binomial, then just FOIL that all out. 1 times 1, 1 times sine theta. Sine theta times 1, sine theta times sine theta. All right, plus cosine squared theta all over cosine theta, 1 plus sine theta. Okay, so we have sine squared plus cosine squared. So what is sine squared plus cosine squared? Sine squared plus cosine squared is 1 from the Pythagorean theorem, right? So we have 1 plus 2 sine theta. Sine squared plus cosine squared is 1. Okay, so that gets rid of them. And then I'm going to have cosine theta times 1 plus sine theta. Okay, 1 plus 1 is 2. So I get 2 plus 2 sine theta equals, over cosine theta, 1 plus sine theta. Okay, and then on top, we have, if I factor out a 2 from the top, I can cancel 1 plus sine theta with 1 plus sine theta, right? Okay, so let's do that. Factor out a 2. 1 plus sine theta will be left, right? Over cosine theta, 1 plus sine theta, and so now I can cancel them. 1 plus sine theta cancels with 1 plus sine theta. Okay, and 2 over cosine. So you shouldn't ever really have a trig function in the denominator because we have all of the reciprocal ones. So 1 over cosine is secant. So I get 2 secant theta, and I believe that's what we were trying to get. Let's go all the way back up and see what we were aiming for. Yep, 2 secant theta. Okay, so we are done here. We have verified that the left-hand side does simplify to 2 secant theta. Okay, so do you see the similarity between simplifying and verifying? You're going to be simplifying in order to verify. Okay, so they just give you the answer that it should simplify to. Okay, so that is it with 2.1. So if you have any questions, again, just email me or message me. Make sure you guys keep up with the homework.